I keep changing the title around, so I think it is best practices for modern apps on platforms as a service in the schedule, but this is essentially it. It's a bit dark, but you should still be able to see everything. You don't see the nice purple background of the slide here. My name's David. I am German. I work for a San Francisco-based company called Heroku. We're also sponsoring, so the booth is out there. This is my email address if you have questions or if you would like to complain or praise this talk privately. If you would like to do so publicly, for the next 40-ish minutes, you can bash me and I have no ability to respond. So, the 12-factor app. Who's heard of that? Hands up, please. Nobody. 1, 2, not like this, please. Far up. Yes, okay, there's a few people. Good. For the people, for the uninitiated, the 12-factor app, it's essentially it is a manifesto. It is a methodology for developing applications, not very difficult actually, very simple to follow rules. And it's a condensed collection of experiences essentially. These experiences come from many years of deploying applications, running applications, and a lot of cloud platforms as a service such as Heroku or Cloud Foundry, or if you want to run your own little cloud of things using Doku on your own infrastructure, follow the 12-factor principles and the assumptions that underlie them. Heroku actually started out as a PHP company. It used to be an agency, and then Ruby on Rails suddenly became very fashionable. So they switched from PHP to Rails and very quickly found themselves with a challenge, namely, how do they deploy an app? Turns out PHP hosting is abundant and cheap, right? Everywhere for $0 to $5, you can get web hosting that works kind of well. There's FTP space, 5 megabytes, but for the average WordPress install, maybe that's enough. For Ruby back in the day, 2005, 6, 7, whatever that was not the case. You would have to do all these things yourself every single time over and over. No web space to just drop your stuff in. So they, over time, realized, okay, to quickly deploy apps, we need to follow these and these rules, and eventually that turned into its own company, which now serves hundreds of millions, actually billions of requests per day. The goals of these principles are you want apps that are scalable, you want apps that are, that's important, maintainable, and also portable. Portable across the same within the same platform, but also across platforms if you desire. You can read up on 12factor.net. That's my lasers work. Oh. Yeah, it's working-ish. Not very well. There we go. 12factor.net has all the rules. But it has 4 very important, I think, factors, rules that you should code against accordingly. Have one code base to do your deploys from. Don't have 2 code bases or something like this for your development or your staging environments. That should be obvious, right? But I've seen even like, not this year, but last year and the year before, people messing around with Samba shares and not floppy disks, but similar, right? Like copy stuff around on production service. Explicitly declare your dependencies, which is Composer in our case. Read your configuration from the environment. Don't hard code everything into config files. I know that in Symfony lands, this is actually something very common and a mistake I make as well, so don't feel bad. And logging should be a trivial matter of logging to standard error and then having external processes aggregate them for you. Dependencies, obviously, if we want to declare dependencies, for Node.js, that looks like this, where you say, this is the express and cool ASCII faces converts pictures. This is not so important, but it's a package, right? But you can also say, this is the system version of Node that I want to run. And we can do the same in PHP, where in the composer.json, we can actually say, this is the PHP versions I have tested, developed, whatever against, right? So 5.3.3 or higher is a PHP version I require. You can even say, this is an extension I need, mcrypt in this case, and certain userland packages. So declare those dependencies. The more of those dependencies you declare, the easier it is for the platform you deploy to figure out, oh, the mcrypt extension isn't enabled by default, but I'll enable it now because it's required by the project. It declares its dependencies, right? configuration, store it in the environment, and read it from there. Because the idea is that you have two deployment targets, the code is the same, and it differs by configuration. Usernames, database credentials, something like this, right? For example, you could be reading the email credentials, hostname, port, user, and password from a config file, and then suddenly traffic to your app spikes, and you realize, well, the internal SMTP server that's configured in these credentials is somehow not catching up. It's being blacklisted by external parties, whatever. So you very quickly go to Mandrill or whatever they're called, SendGrids. Like, there's a bunch of email providers who will take care of delivering email for you, right? And they give you an SMTP gateway. So all you do is change a bunch of config variables, environment variables, restart maybe your web server, and your app picks those up. You don't have to redeploy your application. And in the code, you would then read it using getenv, and you set it, like, for instance, on Heroku or Cloud Foundry using a command like this, and they end up as environment variables available to your application. So these are basic rules you follow, and then you can deploy, right? And the basic principle of a platform as a service is that you don't have to worry about what web server to run, how to run it, system packages, Linux things, security updates. What happens if my disk grows full of log files and I have no space left on the device? All those things should be taken care of for you. So that means, ideally, you just create an app, which makes you an app in the cloud, and then you push to it. So in this case specifically, Git is your deployment interface. So you have a remote called Heroku. You push to it. It detects some PHP app because you have a composer.json, right? And it sets up a bunch of runtime things because you declared them in your composer.json. Then it installs the dependencies that actually exist in userland. Done. And then you have something running. And the underlying principle of that is the build, release, and run phase. That's 12 factor number 5. You have basically a pipeline of steps towards a release. The build step receives the code, runs the package manager's install procedure. In this case, it is Composer, and it runs post-install commands to maybe pre-compile assets, warm up things, whatever. Then the release step makes a package of that and the end vars you have defined, so they are separate. And then the runtime step runs this compiled application. The idea of this here is that you can change config vars without having to rebuild the application, which might take a while. So to change the SMTP credentials that you saw earlier in the example, you just set them, and with the same code base, your app can just be restarted with a new environment, and that forms a release. And then you can always roll back to a previous state of code and or config, right? Which is pretty nice if you break something. In general, you should try to aim for dev prop parity because we all know that SQLite doesn't behave the same as MySQL. So just because you think it's convenient doesn't mean it's not going to break. At the very latest in your continuous integration or testing environment, staging environments, you should have the exact same database, cache, whatever external services, products that you run in development locally, right? Because otherwise you're in for a nasty surprise the day you deploy and then go on a holiday. Apache is not the same as Nginx, even if you think you configured the rewrite rules the same way. They all have their respective ways of entering nasty rewrite loops and stuff like this. Sessions are a very good example. We're very used to, like locally, we develop with file-based sessions because we have just one instance. And those behave drastically differently from any userland session handler. Userland session handlers don't block, right? If you do session start with PHP's built-in file-based sessions, and it's doing something, and there's a second request coming in, that second request blocks on session start until the other process has completed. Once you have user-based session handlers, you don't have that. So locally, you don't have race conditions when putting things into your shopping cart. All of a sudden, when it's in production, you have them, and you wonder why. And you need to start debugging in the live system. apt-get, homebrew, make a vagrant box with your things, right? Hand them out to all developers. So that also avoids a lot of the works on my machine problems that very often we have as developers, or we like to pretend to have. processes. So how does the platform that you deploy to actually know what to run? Right? And this is a very interesting question for PHP in particular. Because if you have a Python app, maybe you have some background worker that runs all the time, listens on a 0MQ or something like that, right? RabbitMQ, for something to do. And then a web process uses GUnicorn. Python has a WSGI specification to interface between web servers and frameworks, and you can stack middlewares in between. And the same goes for Node maybe. Node has, the web server is implemented in Node.js. Ruby has Unicorn or something else. So the web server is written in Ruby, which has a bunch of advantages and disadvantages. But the fundamental thing is that you can fetch this app as a developer, and you type bundle exec unicorn, and you have a running app, because it binds to the port you tell it to. Java has a very long command line. There's my Java joke. It was supposed to be longer, but yeah, never mind. Anyway, the idea is the same. Jetty is implemented in Java, but for PHP, well, the background task is clearly easy because it's a command line thing that listens to a queue, right? But what about the web server? We could run PHP's built-in web server, but that clearly doesn't cut it in production because it's single-threaded and blocks on it even when you request a CSS file, right? So that's not a solution. We can't run a web server in PHP because the fatal error kills the process, etc. Like, it's maybe one day, but not now. So we need a dedicated web server. So for that, this is something you can actually use in your projects. This is something I had to write months ago to get PHP working on Heroku. This basically launches, in production, it's injected into the app. Other systems such as Cloud Foundry use the same thing now. You can use that in Composer in your project, only for dev. And then you can type foreman start. Foreman is like a thing that reads a proc file and launches processes for you. If there is a .env file, it sets those environment variables for you into your app. So you can read from the environment, so you can code according to 12-factor principles, right? You don't have to do it that way. You could still use your old virtual host-based approach, of course. But in case you want to mimic what's happening on the platform that you choose, you can do that. Concurrency. So we have a web process defined, right? But we want to scale now. And so this is the fundamental idea of a cloud: elasticity and scalability, right? I can go, everyone promises that. Oh, automatic, maybe even you can scale up and down with the demands. In practice, it's not that trivial. But in theory, you should be able to do, hey, say, OK, give me 10 of the web instances, and it'll scale up. And then you see them running. And you leave them running maybe for 5 minutes. So you get built for 5 minutes. That's the nice thing about the cloud, right? And you scale back down. Or you do it in a fancy web interface. We have one, everyone has one, and you can just drag the slider and see what it costs per month. So you saw web process. We had a worker process as an example. Now, the problem is that you have deployed an app, but what about the database? It's not initialized yet, right? How do you run a database migration? Well, the code should be in, remember, the same code base. So you don't spread these things out across 5 Git repositories. You deploy everything that the app requires to run in one Git repo. And because it's already up in the cloud, and because it already has the correct config to connect to your database, etc., you can simply run a one-off process, such as, in this case, it's Heroku run PHP app console. You know this, doctrine migrate. And this runs a bunch of doctrine migrations on your database. Done. This takes 10 seconds. It boots an isolated instance for this. And after that, that's gone, but your database is migrated. And to even get a database, you should follow principle number 4, that backing services you treat as attached resources. So don't assume that you have a local host MySQL or something like this. There is an environment variable that tells you what database or databases to connect to. You read from that. Where it exists is none of your business, right? because then easily you can swap out the database by just changing a config var. You can add a Postgres database, maybe a second Postgres database, and maybe a Redis, right? Maybe New Relic if you want. Like it could be, it doesn't even have to be a data store. It could be a logging endpoint. It could be a service that a RabbitMQ. It could be a service that lets you convert videos. And all of the connection information for these ends up in the database, in the config, right? Which is in the environment. So in your environment, you read the Redis to go URL, and you just parse the URL if necessary, pass that to your Redis instance when connecting. Done. Demo time. I'm going to be demoing this app. It almost works. This is an app that I wrote that will, because some of you have filled the Heroku questionnaire, we'll pick a winner later before the closing session. I'll talk some more about this in a moment. And we're going to look at that app now. If in general you want to get started with this stuff, you can follow these instructions. But let's look at this for the moment. Oh, that's very low. Yep. So much for this screencast. I need more resolution. Very good. Okay. So this is our application. I need to rearrange a bit here. And it's more or less a standard Symfony app, right? I have to find a proc file where I say, this is how I want to boot it. In this case, because the binaries get installed to bin, not vendor bin, as you can see by running so I have a vendor directory where the vendor stuff gets installed, but because it's a Symfony Standard Edition project, binaries actually get installed to bin. Now, I already have an application for this on Heroku. I don't want to use that because I want to show how this works. So this application does a few small things slightly differently. In my config.yaml, I import parameters and security, but I also import an env.php. And the env.php tries to read a MongoDB URL, because I use MongoDB, environment variable. If it can't find that, it uses a MongoHQ environment variable. And it tries to find an admin password to protect the whole website, and an API token for getfeedback.com, which is the RESTful thing. And they have an API from there, an import command that I'm going to show you. So the import command imports all these things, but instead of reading something that's hard-coded, it reads a bunch of parameters, such as env.getFeedbackAPI token, right? It uses that when constructing the request to the API endpoint, and this in turn is set by env.php. That's one modification I've made, so I can read envvars, because as of now, but Fabien told me actually that he's working on this, there is no way to reference environment variables in a config. So this is probably the easiest way around. Have a little PHP file that you import that sets a bunch of parameters by reading them from getenv. The other thing I'm doing in config prod is I'm logging to PHP standard error. I can actually do the same in config dev. There we go. And that's pretty much all the adjustments I've had to make for it to run on a platform. And now I should be able to take this and deploy it to Cloud Foundry, to Heroku, to any platform that follows 12-factor principles, right? This looks good. And since I have a proc file, I can type form and start. I guess I have it running already. So there we have this. And I have the console command that lets me import stuff. So this would be a classic one-off process, like I showed earlier in the app and processes. So I would type Heroku run app/console raffle import, give it the parameters it needs, and it runs, right? I'll show that in a moment. Actually, I'll show it later, not now. But when I now go to localhost 5000, admin, and a password hold on. I have my raffle app running locally, right? And I could now pick someone. This person is not actually going to be the winner, but this randomly reads, right? So you guys haven't won, but you could win later. From the drawing. You can check out the code on GitHub. It's on GitHub. Like here. There. Now, I want to deploy this. There is very little to fix. Let's see. That's just a new line. Okay, can push this to GitHub. But the more important thing is I want to deploy this to the cloud, because right now it runs locally on my computer. So Heroku create, and I give it a name. Sorry. Slow phone connection, sorry. And then, so now I have a remote named Heroku, and I push it. Oops, I actually forgot something. Production environment, that's more important. You always need to set this so all the cache warm-ups, compilations, etc. run in the production environment. And then you can push. And because I'm using the Doctrine Mongo ODM bundle, for instance, it knows that, okay, in the PHP, in the composer.log, it requires the Mongo extension. So it's installing PHP now, Apache, and Nginx, so we can use both. And then here it installs Mongo, curl, and PDO, obviously enabled by default, and doing a bunch of things. And it's launched, and I can go Heroku logs to look at the logs. I can also just go to the site, but it's broken because I introduced a bug. It's my fault. So blank page, and it actually shows us a bunch of errors. But this goes a long way of showing you how the logging works, because it's logging to standard error now. This is aggregating it across all instances, right? So I'm running one web server now. I could do scale web equals 10. And now I'm running 10 broken applications. But if I go here, hold on. So you can see the instances booting up and spewing different errors. I promise it'll be, I'll have it fixed by the time the closing session comes around and we pick a winner, because we need to pick a winner. Yeah, but you see the stack trace. This is coming from web.2, right? This is coming from rep.3 and so forth. I'm actually missing a bunch of things anyway. I need a Mongo HQ database. I can do that right now. And I would have to set up a bunch of config vars that you are not allowed to see, because otherwise you can access the database and mark yourself as a winner. But it would roughly be config set, the admin password, and then I set something. I'll do that when the screen is off. And then I'll deploy, and then you can check it out later. We have 10 minutes left, so I'll go back to my presentation, actually. Oh, wait, you know what? I think I have one more thing to do, just because it's fun. It'll still be broken, but packages.org is slow, I guess. Or my mobile connection is slow. Yeah. Yeah, sorry, the risk of live demo is slow Wi-Fi, slow mobile data. I'll proceed. Maybe it'll be done by the time we return to this. So you can check the app out there. As I said, before the closing session, after the lightning talks, I'm going to be doing a raffle. This is if you want to get started. Two more things that are important for today and tomorrow. Outside, there's a bunch of cards. Get a T-shirt if you go to this QR code, or when you go to the main area, there's a Heroku booth. Grab one of the cards. Enter, you get a T-shirt shipped to you, and you can win later. That's the drawing thing that we're going to be doing after the lightning talks. And also, more importantly, come tomorrow to the hack day, please. I know we're competing with Madrid on a Saturday, and maybe after lots of drinking Friday evening, but it's going to be rainy, hopefully. No, sorry. That's mean. That's mean. That's very mean. I'm sorry. Maybe it'll be rainy. And even if it's not rainy, come to the hack day and help make Symfony better, right? That's what the hack day is about. Fix issues, contribute to documentation. Anyone who has a commit and a pull request that gets greenlit by Fabien or another core maintainer, and who pushes an app to Heroku, can win this bicycle. It's an amazing bicycle from Mission Bicycles, and it's like an 8-speed thing, and it's not a fixie. You won't kill yourself. It's a great bicycle. Even if you don't win for pushing an app, you can get a little reward, one of 3. It all says it on the cards that you hopefully have all collected already. Let's go back to see if HHVM is finished. No. Ugh. Okay, HHVM doesn't have MongoDB. Fine. Okay, it's not working. But yeah, next slide is the end. Wait. Rate the talk, right? Don't give me 1 star because it failed. Like I blame the Wi-Fi. No, give feedback. I've already seen that you guys are all giving good feedback on joined in for the speakers. It's important to us to know how we improve our presentations.